talking about today. So what we are presented with is the sheer abundance of digital text that is available. And in the end, what we need to do as evaluators is to somehow come up with an estimate. The best would be one single sentence on a postcard on the result of our evaluations. And somehow this is an impossible challenge to read all through everything that is there. And text mining provides a way to somehow shorten this. So text mining consists of several steps. So first we have the sheer abundance of unorganized texts, and we need to select what we're interested in from these to get our corpus, document corpus. And that is somehow transferred to a data matrix, basically numbers in rows and columns. And through data mining, we can then extract patterns from that. And since we are still dealing with observational data, we can combine that with a causal model of the world, just as in statistics of observational data, and come up with estimates from that. So this is basically the process to get from digital text to estimates we can use in our evaluation. So in the very ancient times of text mining, which is 3 years ago now, we had this policy brief, but since so much has changed, I kind of thought a little bit about this presentation today, and I changed it a bit. So I'm not going to present what we've been writing in the policy brief, but rather I try to come up with a scheme to give an overview of different, with a decision tree to give an overview of different approaches of text mining. So basically, the first question you can ask yourself when you want to approach the topic with text mining is if you have labeled data available. So what that means is, do you have some connection between the unstructured data that is there, the unstructured text you're analyzing on the one hand? Can you connect it somehow with, let's say, an Excel sheet that contains what you're looking at? And if you don't have that, if you don't have the structured data available and just have the text, you would answer no to that question and come to the second decision point, which basically asks whether you have a specific concept in mind you're looking at. So are you looking at, for instance, human rights mainstreaming or fragility or something like that? If that's not the case and you still answer no, then you would come up at the first part, which is unsupervised learning. And what unsupervised learning basically does is to learn patterns from data and summarize the data using different methods. So one of these methods would be clustering, which groups similar documents together. So you can have a very large corpus, and document clustering will somehow differentiate this corpus into different clusters. A second, and that's the example I brought, a second task would be topic modeling. So basically what topic modeling does is topics are basically distributions or clusters of different words, and documents are represented as distributions over topics. So you basically have two different steps of summarizing topics from large amounts of documents. And what you can see then here on the right side, so the left part of the right side, is the intertopic distance map, which basically shows you the different topics and reduces the complexity to 2 dimensions via principal component analyses, and shows you the different topics. And the topics, the more close they are to one another with regard to the words that are typical of that topic, the closer they are together, and the larger the topic is, the bigger the bubbles are, basically. And on the right side, you can see the different words that are representative of this topic. And topic modeling is a great example on how text mining combines interpretative appraisal, so a more qualitative approach, with statistical techniques. because you can extract from these topics these word clouds, and you can basically look into the source documents and read through the different topics at the level of the document. So you still need to interpret, summarize, to name and label the different topics. So yeah, as I said, it's a good example of how qualitative and quantitative approaches go together in text mining, and it's not basically purely statistics. So this, for example, would be a topic of sexually transmitted diseases, and the analysis was on World Bank evaluation reports between 2000 and, I can't see that right now, but I think it was 2020, which we summarized to get an idea on the topics that are in these evaluation reports, how they develop over time. Yeah. Okay, if you somehow know what you're looking at or looking for, and then you would answer yes to the question that the target output is somehow predefined because you know what you're looking for, the concept. And then the next question would be, are you looking for a native named entity? So are you looking for something like a location, a person, a date, an organization, or similar things? Then you would end up with named entity recognition. And what we did in this regard is, we know that effects of development cooperation are often local, and many phenomena we deal with in evaluation of development cooperation vary subnationally. But still, most evaluations, if they are quantitative, rely on statistical analyses of country year data. So there's kind of a mismatch between the level of analysis and the unit of analysis or the phenomena of interest we are looking at. And to solve that, we try to make use of all the data of where development cooperation projects are located in project documentations. So what we did is we basically took all evaluation reports from the German implementing organizations, extracted from these the locations, which are one type of named entities, and then automatically assigned longitude and latitude to these entities. So this allowed us to somehow bring together our unit of analysis and the data we had, because we could then look at the distribution of development cooperation projects subnationally. So this is one example. On the left, you can see the different PDF we had, and you can basically select the PDF. You can then see the locations. The bubble again relate to how often a certain location is mentioned in the document or documents. And then you can again click on these, and you can read the context where the location is mentioned. So you can get an idea on why this location is mentioned, and you can qualitatively assess whether it makes sense and whether it's really a project location or whether it's a place where, let's say, a contract was signed or something like that. We also used it to look at the placement of German development aid in fragile contexts. So this is Colombia. And what we asked ourselves was whether German development cooperation really targets those areas that are fragile, because state fragility varies substantially between different parts of Colombia. So taking this to the subnational level and combining the data with other subnationally disaggregated data, of which there's more and more and more available, allowed us to get more precise estimates of whether development cooperation goes where fragility is, so to say. Okay, so let's say you know what you're looking for. You're not looking for a named entity. and you don't have any resources for training. So this is probably quite often the case. And then what you can come up with is so-called zero-shot classification. So basically, you present to a model a string of text what you're looking for, and ask the model in plain words to classify a certain string of text. That could be a tweet, that could be a newspaper article, anything basically. And you basically ask the model, please classify this according to, let's say, these 5 classes. And the model, the modern large language model, will come up with an answer for that. One example that works rather well is sentiment analysis. So I have to say, we didn't do this, what you see here with the modern large language models, because they were not available, at least for us, at that time. So this is simply an example that is also applicable to zero-shot classification. So what you see here is a sentiment score. So basically an analysis of the emotional tone of newspaper reports, differentiated by regional newspapers, which is the blue line, and national newspapers, or national newspapers as the yellow line. So what you can see here is that the tonality of regional newspapers with regard to their reporting on development cooperation is more positive than the tonality of regional reports. So what you basically can look at, how positive do different stakeholders refer to development cooperation. You can look at social media posts. You can look at the comment section of newspaper articles to get an idea of how the public, maybe, depends on how much you trust the sample, how the public feels about development cooperation, about different types of development cooperation, and how this develops over time, or how this is affected by certain events, for instance. Okay, so let's say you have some time for training. Then you can do 3 things. You can do manual labeling. So basically, you take you take a sample of your data and you label it manually, and then you show the model the structured data, your Excel table, and you show it to the model, and you ask the model to classify the whole data set based on the sample input. And then by hiding some parts of the data, you can estimate how good the model works. You can also use something called active learning, where you reiterate this process. So first of all, you have the same input data, and then you get an output, and then you ask the model, are there, for instance, you can ask the model, are there certain classes where you're not really sure? And so then you would qualitatively reevaluate those instances where the model is not that sure, which is a very efficient way to train the model, so it leads to more qualitative or qualitatively better results in the end. And a third approach is to find some type of external data that is similar enough to the issue at hand, and use that to generate training data. Okay, I think I will skip that one and just briefly talk about explainability. So with the advent of these modern methods, one question really came to the fore, that is the question of explainability of these artificial intelligence models. Because the modern neural network models are impossible. I don't know if it's correct to say impossible, but many experts in the field say it's, at the current state, it's impossible for them to understand how the model came to the conclusion. So if you ask ChatGPT and it comes up with an answer, then it's not really clear on where this answer comes from. So it's not explainable. You can ex post. You cannot say what parameters of the model led the model to come to this specific conclusion. And this is obviously in many fields a very big problem. And it's also a very big problem in evaluation, I would say. So if you want a model that is explainable, then you can resort to some of these results where I will now skip the example, but the more traditional approaches of classification that rely on logistic regression, naive Bayes algorithms, support vector machines, so these are white box mechanisms. In the end, you can really say where the result came from. If you don't care too much about explainability, then you can choose the left path again, which will lead to the neural network and the deep learning models, which will give you much better results on many issues, but you don't know why, basically. So, so one example, and this will be the last example here. So what we looked at is climate finance. And in 2009, as you may all be aware, the signatories of the Copenhagen Accord agreed to mobilize $100 billion by 2020 for climate change adaptation and mitigation. And reporting standards are not standardized among different agencies. So we really tried to come up and understand how this reporting happens, and it's very, very hard to do so. So there are these RIO markers, and they are part of this reporting practices. And basically, you have all the 8 activities in the OECD DEC dataset, but around 1.5 million rows, and each of these 8 activities, so there's a lot of missing data, but let's leave that out here, should have a RIO marker, which is 0, not related to climate change, 1, partly, and 2, completely, basically. And use this as a coefficient, and then you basically come up with how much climate finance you have. And what we did is we used an existing data set. So this will be the third type of training. On this very data set, which we evaluated the RIO marker based on the project description in the OECD DAC dataset, and basically re-evaluated this coding. And then we used that, it's about 4,000 rows, I guess, to apply it to the whole dataset of CRS to come up with an estimate of how much over-reporting takes place in climate finance. And I think this is a very good example for a classifier, because I think we all agree that it's basically impossible to go through 1.5 million project descriptions and come up with a conclusion within a few years. So thank you for your kind attention. And if you're interested in these applications, then please feel free to contact me. And here are some of our reports that where the example came from. So thank you very much. And I'm looking forward to the discussion.
Thank you very much, Thomas. I think the aim of this breakout session was really to be practical and to complement the other sessions with really the tools that may be useful for you going forward. And I think that's exactly the core of what you're presenting here. I would have many questions, but I'm sure the other participants will also have questions. I would just have one for you. There was a recent article in the Wall Street Journal about ChatGPT, and the key message from this article was indeed the issue of explainability and clarity of the processes that lead to the results. And in fact, one issue is also the trade-off between being very comprehensive in terms of the source of information that you use and the trust that you may have or may not have in this source of information. So what's your experience in checking or waiting for the reliability of the evidence that you put in the machine to come with the results?
Yeah, thanks. Yeah, I think this is an extremely important question. basically, I was looking for different. I was asking ChatGPT to come up with some recent peer-reviewed articles on how to measure CO2 emissions. And so it presented me with 2 articles, and I was really excited because I thought they really sound perfect. And I kept looking for these articles, and they basically didn't exist. So ChatGPT somehow came up with these titles of articles that are not there. So this is obviously a problem of reliability and trustworthiness. If I ask ChatGPT to let's say annotate my my text and add citations to my text, so I think the bias comes from the training data, and biases in the source data can also come up in the final model. That's a huge problem. And I think one problem is that transparency and explainability are somehow inversely related, right? So the better the results are, the harder it is for me to understand where the results come from. And at the same time, I kind of, to keep up with the pace, I have to use these more modern methods to come up with better results. But then I don't understand these results, right? So, okay, so what can we do? I think one thing, peer review, right? So we all know about peer review, and this is, we have to somehow peer review the results that come out of the language model, and we have to learn on how we chat with ChatGPT, and we have to learn how to ask questions, and we have to really get the experience of what comes out. And maybe on a more abstract level, we somehow have to develop benchmarks against which we want to assess the credibility of the model. So maybe we could come up with a benchmark for evaluation to first test the model against, and we apply this benchmark for every result. And if it passes, so to say, then we trust the model, and if not, then not. But I'm not aware of evaluation-specific benchmarks in the field. And maybe a last point. I mean, there's so much research on this, and there are more recent approaches that try to differentiate the understanding of natural language from the retrieval of information, and somehow keep these things separate so that the model is good in understanding, but at the same time, you know where the information comes from, and you know it's not the whole internet, but rather a certain corpus of documents. So yeah, thanks.
Thank you, Thomas. I will now give the floor to colleagues in the room, and also colleagues online may want to ask the question directly on the chat, and we will convey the questions. I see we have 1, 2, 3. Aaron, please. If you can introduce yourselves. And
my name is Aaron Garban, and I work for the EIB Evaluation Division. Just one comment and one question. The example from ChatGPT, I had the exact same experience with what you had with when looking for peer-reviewed papers. So I think it's and also recently in the press we have seen quite a lot of reference to the quality of the information that we receive from ChatGPT. What I would warn against is to take sort of like a generic conclusion out of that on the reliability of text mining tools in general. So I think we need to be aware that ChatGPT is a very generic tool that was designed to emulate human speech, and most or quite a lot of the deep learning tools for natural language processing are much more specific, much more easy to test, and so on. So I think I would separate the explainability problem and the reliability problem, because the explainability problem is kind of like more generic to deep learning, but I think the reliability is much more. We can fine tune the reliability much more a specific tool, then we can do it in the case of ChatGPT. My other comment is actually a question. Like, I was wondering what kind of tools are you using? So, are you using NVivo? Are you using Python? What is the standard toolkit for like an NLP-based analyst? What kind of softwares do you have on your computer when you're doing this kind of analysis? Thanks.
Maybe we'll take a few questions in a row and we'll let you reply. Joël?
My name is Joël. I also work in the evaluation.
Joël, microphone.
Sorry. I have a few questions because my previous background before going to the EIB, I was working with big data on the econometric side, economic side. So also working with supervised and supervised data, with the curse of time. Working with this big model, supervised and supervised learning. You transform the curse of dimensionality into a blessing. Of course, we know that there is a trade-off that, these models are black box, so you cannot link, saying A imply B, because the aim is that, we know that all the data are imprecise, data are noisy. You want to extract a signal from a lot of data and potentially noisy data. So in a way, we know that, if we have a very little model where you can really explain the causality with 3 variables, you can tell a story, but you are missing a lot of information. You will have omitted variable bias. So, I was in the world of forecasting, and we know that, this big data, supervised and supervised, so whether you use factor model, Bayesian, neural network, works much better than the rest because they deal with all these problems. Now, a way to evaluate this model, especially in economics, you need to test the model. So you see, you use the model which is performing the best. So you do a pseudo real-time forecasting exercise to make sure that it works well. Here I was wondering, because you mentioned it a bit, Aaron, you talked about it. So first, what I don't understand because end of the day, as I said, the point is to work with massive amount of information. How you combine everything, a lot of information is correlated, noisy. This is why you don't want to pick one series, because we know it very often when we pick one series for a regression, at some point it breaks down and you want to include everything. So first, is it that important I think when you use this kind of method, it's not really important to explain the causality, saying it came because of there, A, B, C, D. It's, you exploit the signal from many sources of information. This is, so for me, so it means that it's, we are not there into explaining really where it's coming from, but also where I have a bit of an issue is, how, as you said, how do you assess the reliability? Because, in economics, whenever you do a model, especially in forecasting, you test whether your model works well. So you have it. The model is giving a prediction, and then you have the realized value, and then you can decide which one is working well. You have different metric, and when is it working well, different period, different country, etc. So I was wondering, how is this used in this kind of analysis? And also, just maybe a stupid question about the word text mining. Normally, when we talk about data mining, it is viewed as something, really trying to get some result, but misleading. Searching the data up till you come to something, and people are going to say, look, your result, guys, if you try 300 regression, at some point you have something significant, but it doesn't matter. That's maybe more of a joke, but I think the name, given that it has such a negative connotation on the other side, data mining means really that your results are flawed. So how do we connect the dots on this?
Okay, we'll take last set of questions.
Yes, so my name is Michael Potter. I'm working for the Evaluation Support Service of DG INPA, the European Commission. I was wondering if there is a bias north-south in the treatment of the data, notably between the owned data and the origin of the data that might be from beneficiary countries, beneficiaries of the development aid, for example, and the availability of training data that might be Occidental data that might be too few compared to what we want to analyze. That would in turn create a confirmation bias to some degree, categorizing the beneficiary data as per Occidental values, and again doing exactly the same thing as we have been doing all the time. So, is there a north-south bias and risk in terms of maybe data protection in this case?
Okay, yeah, thank you very much, Aaron. Yeah, I completely agree with your comment with regard to the question on software. In the past, we have worked with R and also with some front ends. For instance, the front end I showed on the topic models, where you can basically, it provides a front end to the R environment because R is exclusively text-based. And so together with researchers from the University of Leipzig, who are experts in natural language processing, we developed the front end. So basically everyone could interact with R and everyone would be guided through the process of the analysis, because it involves a lot of very small decisions, and sometimes it's really hard to know how to make these decisions. So this is what we did in the past. In the more recent approaches, yeah, they are so these transformers and all that stuff, they are really hard to tackle, because so our IT at DEVA, it's not possible to have these models there. So what we do there is, so I think it's almost exclusively in Python, but we cooperate with universities that have the computing power in the background that run these models, and then we basically team up with the two domain experts, so to say, and chit chat on these questions. And I think this is where it's probably going. So you somehow need a connection to a cloud server, or you have to externalize these things. With regard to Joel, I think that so a few answers. So first of all, it's still in the observational paradigm. So it's still observational data. And that's what I was trying to get at the very beginning. So we need to come up with a causal story from observational data and from texts requires us to make certain assumptions we can never prove to be true. So this is why it's extremely important to tackle all these problems with domain expertise, and to also, and I think this is where evaluation can also improve, to make these more transparent, right? I mean, still evaluation has something like inception reports and concept notes, which go into this direction of making your assumptions explicit before doing the analysis. So I think evaluation is somehow predestined with regard to these questions of pre-registration of research, which is a very important topic, for instance, in medical and biological science. So first answer, to extract causal estimates, we always rely on domain expertise that we can never prove to be true. So, and we have to make that explicit. Okay, so how can we assess the reliability of the model? So, I mean, there are very straightforward approaches. So basically 10-fold cross-validation. So you hide 10% of the data set, you let it classify, and then you see how good it is, because you have manually labeled it, and they can basically, so the model I presented on the text classification of the climate finance, that reached 90% accuracy of the human classifier. So basically you always come up with a benchmark, human-like behavior, and then you can see how it performs. Okay, and the last part, one other opportunity I think is method integration. So we came up with this estimate of over-reporting of climate finance of about 80%, 70%, 80%. So that was very, very high. And we kind of doubted the results. So what we did then is we got a second data set that was a really in-depth analysis of project documentation and country experts that assessed for few projects how much they relate to climate finance. And what we then did is we combined the estimates from the model and used a Bayesian updating to basically estimate what a qualitative researcher would have found if he had looked at all the 1.5 million. And you can come up with a Bayesian theorem, you can come up with an estimate and a bandwidth of certainty. And this is what we did. So you can combine different types of evidence and ideally synthesize them mathematically, so you can really show in a transparent way how you come to your conclusion and where the uncertainty lies. And then we end up with 30%, but we come up with something between 20 and 40. So it's also a nice way to communicate that. Okay, and the last question, Michael, with regard to the North-South divide. I think this comes back to the question of what model you use, because these large language model right now, they are trained on US data. I think like 80 to 90% of the data comes from the US. So they surely have the problem you were talking about. But the more you come into the area of models that you develop specifically for your task, what you were also referring to earlier, the less of a problem it becomes, because you can then decide on the corpus that is included in the training of the model. So I think we should really be aware of these very modern methods and really look at where the data comes from and how that reproduces bias, because it does reproduce biases that are present in the source data.
Thank you very much, Thomas. So we will now open the discussion to colleagues joining us on the chat. In fact, the chat is very active. There's a lot of discussion currently. And we have Rick Davies, who is on the line. And Rick is quite known in the area of evaluation for sharing tools, methods, and vulgarisation, to say in French, of methods. So I will ask him if he would be willing to maybe intervene on the call to yeah. I unmute. Voilà.
So Rick, if you'd like to unmute yourself.
Yes, I have. Can you hear me?
Perfectly.
Yes.
Okay. I just wanted to comment on the question of accuracy of ChatGPT type services. There's no doubt there are serious accuracy problems with the responses that you get there, and I've spelled out 3 different types of problems in the chat function. You can get unreliability of answers to the same prompt when the same prompt is repeated a number of times. You can get prompts which are internally inconsistent, the content, you can get responses which are internally inconsistent, and you can get responses which are externally inconsistent. So you follow a link and you discover there's no actual link, working page, web page behind it. But I think the thing we need to bear in mind in balance and compensating with that sort of view is that the clue is in the name. It's called ChatGPT. So primarily, you need to remember this is a dialogic type method of inquiry. So it's not like you just pose a question and get an answer and then that's it. The clue is, once you've got the answer, trying to refine the prompts in such a way that you get ChatGPT to focus in on what you really want and avoid the errors that you've identified, and you do that by tuning the content of your prompt. And so there's a lot of work going on what they call prompt engineering, devising carefully constructed prompts that are effective in their results. And there's another way of dealing with errors, which I think is I'm only just starting to explore it at the moment. There are various interfaces that you can use to interact with ChatGPT, which allow you to adjust various parameters that affect the performance of ChatGPT, particularly the diversity of responses that it generates. And I think this is another area where the more we learn about how to vary the parameters affecting the performance of ChatGPT, the more effective we'll get the responses we will get. I think the other point to make is that ChatGPT as we all know, does lots of different things, but one distinction is between, you might call, the really creative work where it just writes science fiction stories on request, and others which are much more analytic and working particularly on a body of text that you've submitted to it. And from an evaluation point of view, analysing existing texts rather than writing works of fiction is definitely the territory that I'm interested in. And I think in that area we can identify and results which are verifiable for internal and external consistency and reliability. Even in that area, I think we need to make a distinction between exploration and exploitation. often there is a piece of text which we want to extract the maximum value out of, but sometimes it's useful just to generate a lot of different ideas about something, in which case getting it to be more creative can be as useful as getting it to generate reliable results that come back in the same form all the time. Sorry, I'll stop at that point. I've been talking longer than I expected.
Thank you. It's most appreciated for your inputs. We will open for more questions if colleagues have other questions they'd like to ask. Or maybe you wanted to reply to Rick or to complement or on the chat.
Yes, Marcello, you had a question. Maybe I'll just read it. You were asking whether it's realistic to develop our own models, and what's the inherent bias in using transfer learning? What is the risk of inheriting bias when using transfer learning?
So, are you able to build your own model? It depends on what you mean. I mean, you won't be able to build a model like ChatGPT unless you have a large amount of money. So I think ChatGPT costs $100,000 per day or something around that to maintain, and that does not even include the whole training process. And also the training of ChatGPT, probably no one really knows how it works, but so how many human interaction is in there. But what's for sure is that there's a lot of human interaction that has been fed into the training of ChatGPT. So I think rebuilding that stuff from scratch is very unrealistic, but still building on these models, and some of them are open source, related models are open source, building on these and training them to your specific question and task at hand is definitively possible. Although from my perspective, I would always rely on domain experts to really do that and to assess the reliability of this models. What are the dangers of biases in transfer learning? I think the biggest danger is not being aware of them. So as I referred to multiple times, it's really hard to, if you get these results, they are so impressive in the very beginning. So I was super impressed when I interacted with that machine, and it's unbelievable how good these answers are. But it takes a while to understand and to get to see these biases. And you have to be a domain expert, I guess, to assess whether what the model gives you as an answer can be true or not. So you still have to think for yourself, and you have to evaluate for yourself, and you have to be very aware of these biases, and otherwise the model will reproduce them, and that will be a problem.
Thank you very much, Thomas. Any more questions on the chat or in the room? Yes, Aaron, please.
Just one question of curiosity. According to your experience, when you do your resource allocation for text mining based analysis, like what extent of the time and effort is going to processing and pre-processing your text, and what extent is about the analysis and interpreting the results? So how resource intensive actually is to put the data sets together, like, I don't know, putting all the strange format PDFs in the right format to be for the software to be interpreted and so on. I just wonder to what extent it's a problem or not.
I think it's becoming less and less a problem the more you do, because so for instance, in our work, we work a lot with project documentation from the ministry and from the implementing organizations, and also with evaluations. And once you have the evaluations pre-processed and you have them in your data set, you can basically update that data set every year, and you have the corpus there. So being the first is super stressful, and you will make many mistakes, and it will take a long while. But once you're done with that, it gets easier and easier. And the same is with training. So when I started with that, I probably made every mistake possible, and sat there night by night and was super frustrated because I didn't know it would take so long. But now it kind of works better and better, and I can share the documents with colleagues in a certain format that is suitable for analysis. And the pre-processing is less and less important with the advent of these new methods. So stemming and all that process steps, it's much more easy to feed documents to these more modern large language models than it was before with the older methods.
Michael?
Yes. A bit of a concrete example. At DG INPA, we're trying, not me as not part of the team, but they're trying to structure recommendations in and automatically identify recommendations and lessons learned from reports. I will not talk much about the project because I don't know if it's efficient and if it's working as they expected or not. But I was going to ask you, how would you go about this kind of idea of you have evaluation reports, let's say, in various levels of forms and also depth, quality maybe. How would you assess them? And I thought about it when you talked about native entity recognition, and how would you go about making this kind of corpus where you can pick up a recommendation from a report without actually reading the full report yourself? That's what we need, right?
Okay, so I think that's a very tough question to come up with a research process in 20 seconds thinking. I think a very modern approach would be to look into these retrieval-based methods, although I'm not sure whether these are available right now. So this would allow you to use the ability to understand text from the large language models and at the same time define the corpus it should work on. So what definitely works is you can ask, for instance, ChatGPT or a model like that to please summarize a certain report and provide a link to the report. So that works, and then you can read through it. The best would be the author of the report reads through that and assesses whether that's a valid way to summarize the conclusions. So this would be one way to do it, because I think it's a very tough task, because you have to have a lot of semantic understanding of what is meant. And many of the examples I mentioned was rather to extract locations and georeference these, which is much easier, right? Or a sentiment is also, I mean, it's a bit harder, but it's still easier. Or classify a very specific class, like it's related to climate change adaptation or something like that. And basically what you want is to read the text, to identify what's important and to summarize it. And I do not have that much experience with that. And I would be very aware of the limitations of these modern methods, although I would probably guess that the results are probably quite impressive. If you do that and show it to ChatGPT, then in my experience, it will do a very good job in summarizing that, probably.
We have one more question on the chat, and then we will conclude.
Yes, we have a question from Rick Davis, who's asking if you have any experience with extracting causal models from text documents.
Yeah, I think I can give a very brief answer, which is no.
Okay, I think we just to sum up the discussions. For me, as an evaluator and as somebody who commissions evaluations or who designs evaluations, this type of discussion is very useful because it helps me identify potential questions that without these tools I would not even ask myself, because I would assume there would be no tool to answer these questions. So by knowing that such tools are available, they're asking the question as an evaluator, and you know that maybe progressively tools will be available to help you evidence the point. So that's, I think, one of the key useful aspects, I think. So we discussed very important aspects. So first, explainability, this aspect of the transparency of what you get from the data, which is a key issue and is yet to be resolved. The reliability of data, which, as you suggested, may be partly addressed with peer reviews, benchmarks, testing the model, but also, I guess, being transparent about the limitations, what it can and cannot do, or how you should use the data. And also the actual purpose of such tools. Is it about exploration or about exploitation? This also determines what you may achieve from these tools. I hope this was an interesting session for you. So we'll continue with the rest of the sessions, but we will close now the breakout session. Thank you very much. Thank you.
Thank you.